Hello, I welcome you all in this presentation related to the subject fundamentals of the manufacturing processes, and we are talking about the grinding process. In the last few lectures we have talked about the fundamentals related to the grinding, and today we will see the grinding operations, or these are also termed as grinding processes. The grinding is used for giving the desired finish as well as the control over the dimensions so that accurate size products can be made. But this is used for smoothing or finishing of the flat surfaces, cylindrical shape components like contours in form of threads, maybe holes, and gears, etc., and various such kind of the geometries can be processed by the grinding process. And for that purpose the different types of the grinding is used, like one is surface grinding, which is used for primarily the flat surfaces. Then cylindrical grinding, it has a very large range of the varieties. One is like center type, where the workpiece is held in the centers and along the particular axis, and another is centerless process. Both can be external and internal cylindrical grinding, internal and external cylindrical grinding. So, this also centerless also comes in the external and internal cylindrical grinding. So, internal cylindrical grinding means the cylindrical hole like this exists in, and external cylindrical grinding means the external surface of the cylinder will be processed. So, in the centerless means there will be one chuck on that workpiece will be held, and then it will be subjected to the grinding. In case of the centerless, the workpiece is simply placed onto the rest like this, and then with the help of the supports from the two sides, one with the help of regulating roll and the grinding wheel, the workpiece is placed in position for the external grinding, and likewise we have arrangement for the internal centerless grinding. In addition to the surface and the cylindrical grinding, there are other grinding approaches, like one is called creep grinding, wherein the very high depth of cut and very low feed rates are used. So, depth of cut may be like 1000 to 10,000 times higher than what is normally used in the conventional grinding, while the feed rate is proportionally lower, means 1000 to the 10,000 times lower than the conventional feed rates, so which are used. Another important requirement for creep grinding is that it very rigid, high power and a robust machine is needed for this, because very high cutting forces are generated during the grinding, but at the same time it offers the advantage of the high MRR and good control over the dimensions and surface finish, as well as the surface temperature of the workpiece is also low when the creep grinding is used. So, these are some of the grinding processes. Apart from this, there are other grinding processes which may be termed as other grinding operations, which includes like polishing, buffing, then we have honing and lapping. All these are used for producing very high lustrous surfaces, so that they can be used for the purpose they are being developed. For the cylindrical grinding, there is one more classification wherein, like, this is the workpiece, length, and this is the grinding wheel. Grinding wheel is rotated about its axis, and radially it is fed in. So, this is called in feed, that will be deciding the depth of cut. The workpiece is also rotated, and but during this situation of the grinding, when the grinding wheel interacts with the workpiece, only this area will be processed. So, in order to cover the entire length of the workpiece is fed traverse wise also. So, traverse movement of the grinding wheel is given parallel to the axis of rotation of the workpiece. So, movement of the grinding wheel parallel to the axis of rotation of the grinding wheel. So, this situation is similar to that of the turning, where tool remains fixed, but here grinding wheel is a tool which is rotating. Rest of the movements are same as that of the turning. This kind of the grinding is termed as traverse grinding. Here the width of the wheel is smaller than the length of the workpiece which is to be processed. On the other hand, if the width of the wheel is this is the say workpiece, and this is the grinding wheel. So, grinding wheel will be rotating, in feed will be given. Since in this case the width of the wheel is bigger than the width of the workpiece or the length of the workpiece. So, just a radial in feed is needed for giving the depth of cut, and no traverse movement is required for this purpose, and this kind of grinding is called plunge grinding, plunge in grinding, or plunge cut grinding is also it is termed as. So, these are the two broad classifications for the grinding, cylindrical grinding, with regard to the size of the grinding wheel and the length of the workpiece which is to be processed. So, now schematically there are so many kind of the arrangements for the grinding which are used for different types of the grinding operations. So, that is what we will see now with the help of the PPT. So, here what we can see here, like say this is the surface grinding. So, in case of the surface grinding, there are two possible things. There is a flat surface, workpiece is subjected to the grinding. So, in one case, in both the cases workpiece remains flat. This is what we can see. For surface grinding, generally the workpiece remains flat and horizontal position, but the axis of the grinding wheel can vary. So, in this kind of arrangement where the periphery of the grinding wheel is working, this is called peripheral grinding, and in this case that there are two types of the options. Let us see first the movement of the grinding wheel. So, grinding wheel is rotating as well as crosswise movement is given, and the radial in feed is also given to give the depth of cut, but the workpiece is reciprocated in this reciprocated horizontally in order to cover the entire surface area. While in another arrangement the workpiece is flat, rotational movement is given to the workpiece, transverse movement is also given to the transverse movement, or cross feed is also given to the wheel to cover the entire area or the surface of the workpiece, and the in feed is given to control the depth of cut. But instead of the reciprocating movement, here the rotational movement is given to the workpiece, so that all surfaces can be covered under the grinding wheel, and they can be processed. This is the both these are examples of the peripheral grinding, where periphery of the grinding wheel is being used for performing the grinding. And another grinding is face grinding, where the face of the wheel, like this is the face of the wheel, this is being used for the grinding purpose. So, here in this case the rotational movement is given to the grinding wheel, and then radial in feed is given while workpiece is reciprocated like this case. And similarly Here workpiece given a rotational movement, and then radial in feet is given to the grinding wheel in order to give the depth of cut, and then additional rotational movement is given to the workpiece. So the rotational movement, there are two types of movements which are given to the workpiece. One is reciprocating movement, another is rotational movement. So in both the cases, whether it is face grinding or the peripheral grinding, the two types of the motions are being given, while the workpiece while the movement of the grinding wheel is a rotational as well as in feed, it involves in case of the face grinding operation. Now coming to the cylindrical grinding, in case of the cylindrical grinding, like this is the workpiece which is being subjected to the grinding, like say it is cylindrical shaft and this is the grinding wheel. So length of the shaft is more, means surface of the workpiece which is to be subjected to the ground is much greater than the width of the wheel. So apart from the rotational movement to the wheel and the rotational movement of the workpiece, we need the transverse movement of the grinding wheel also. So this will be the case of the transverse grinding, and a radial in feed is given to the grinding wheel, so that required depth of cut can be obtained. And this is an example of the internal cylindrical grinding, where workpiece inside the cylindrical hole of the workpiece which is subjected to be grinding, then this grinding wheel is inserted inside the grinding wheel, and then it is radial in feed is given, so that the wheel surface comes in contact of the surface of the internal surface of the workpiece in order to perform the grinding. So here what we can see, transverse movement to the grinding wheel as well as radial in feed is given, so that required depth of cut can be achieved. At the same time workpiece is also rotated and wheel is rotated in order to perform the internal cylindrical grinding. As I have just explained, there are two types of the motions which can be given as per the length of the workpiece as well as the width of the grinding wheel. This is the case when the length of the workpiece to be processed is bigger than the length of the width of the grinding wheel, then we need transverse feed. So the transverse feed is given in the direction parallel to the axis of rotation of the workpiece, while in another case where the width of the wheel is bigger than the length of the workpiece which is to be processed. So we need simply the plunge cut or the plunge in is needed. So just radial grinding wheel is to be fed radially into the workpiece, so that the required cut can be made to achieve the desired size and shape. This type of the cylindrical grinding is performed for finishing the products like axle, crankshaft, spindles, bearings, bushings and rolls for the roller mills. These are the photographs of the internal cylindrical grinding, where in workpiece is held in the chuck and the workpiece is rotated. This is the internal surface, this is the hollow cylindrical object, and internal surface of the workpiece is being processed by the grinding wheel which is in contact with the internal surface of the grinding wheel. This kind of the operations are normally done for inner bearing races and bushing surfaces for the finishing purpose, and the surfaces which have been hardened. Then coming to the centerless grinding process. In the centerless grinding process, there is no need to put the workpiece on the chuck or on the center, but it is simply placed on the rest blade. So though this is the how workpiece has been placed on the rest blade. So but it uses one side the grinding wheel, another side regulating wheel. So a regulating wheel is given some kind of the inclination, which this is what we can see here. This is the grinding wheel, this is the regulating wheel. So this inclination is given to the grinding wheel, means vertically regulating wheel is inclined vertically by an angle I. So when this angle is given, so rotation of the regulating wheel when it is in contact with the workpiece under pressure with the grinding wheel, then it leads to the longitudinal feed to the workpiece. Because of this angular movement of the regulating wheel only, we will be in position to move the workpiece all along the width of the grinding wheel, so that entire length of the workpiece can be processed. For this kind of the external, this is the external cylindrical grinding, where external surface of the cylinders will be processed. So but this kind of it's a very quick process. Just we need to just place the workpiece on the rest blade and between the grinding wheel and the regulating wheel, so it does not take much time. So this is justified also for the high volume production purpose. The speed of the grinding wheel which is used for this centerless grinding is can vary from 1200 to 1800, and the regulating wheel rotates at a lower speeds, but it is inclined at certain angle so that the feed can be controlled. So feed rate which can be given to the workpiece in case of the centerless grinding can be obtained from the pi d r n r sin I. So what these are? D is R is the diameter of the regulating wheel. Similarly, NR is the rotational speed RPM of the regulating wheel, and I is the inclination which is given to the regulating wheel. So by adjusting the diameter, rotational speed and the inclination of the regulating wheel with respect to the vertical plane, like this is the grinding wheel. So regulating wheel is inclined at a certain angle like this. So this angle from the vertical plane is termed as I, and its rotational speed decides the rate at which the workpiece will be moving past the grinding wheel. So the feed rate of the workpiece can be calculated for the centerless external grinding process using this equation. So we need to regulate the diameter, RPM, and the angle of inclination in order to have the desired feed rate. Now the internal centerless grinding process, it uses the two rolls, two support rolls like this one another, and between the one regulating wheel. So between the regulating wheel and two support rolls, workpiece is placed, and the rotation of the regulating wheel governs the rotation of the workpiece onto the support rolls, and a grinding wheel is brought in contact with the workpiece in the inside surface. So rotation of the grinding wheel in this situation removes the material from the internal surfaces, as well as the inclination given to the regulating wheel helps to move the workpiece past the grinding wheel, so that the entire length of the workpiece can be processed. So but there is one additional advantage, that this kind of the workpiece is when the internal centerless grinding is performed, it produces very concentricity between the internal and external diameters. So that is especially useful for the roller bearing races. Now creep feed is the another grinding process wherein very high depth of cut and very low feed rates are used. Depth of cut can be as high as 1000 to 10,000 times greater than the conventional than what is used in the conventional grinding processes. This is what we can see schematically shown in these two diagrams. Here this is the grinding wheel and the workpiece, and the in feed or the depth of cut is very little. This is what we can see, while on the other hand for the creep feed grinding, the depth of cut is very high, but the translational speed which is used or the feed rate which is used for this condition is extremely low, which is in proportionally means the whatever is the increase in depth of cut, proportionally the feed rate is reduced for the creep feed. This kind of the process results in a very high metal removal rate and very good control over the dimensions, and very less temperature of the surface of the workpiece is achieved in this process. So this is a very recently developed process. Apart from this, the creep feed, surface grinding, cylindrical and internal cylindrical grinding, which is like internal as well as external. There are few other grinding processes like the honing and lapping, polishing, etc. So we will talk about the honing. Honing process basically uses the abrasive sticks which are fitted in a honing tool. So, honing tool is nothing just like a cylindrical object wherein the sticks are fitted like this all around the periphery of the honing tool like this. So, and this honing tool is rotated, and then this one will be inserted in the object which is to be processed for finishing purpose. So, basically honing is used for finishing of the finishing and correcting of the holes, correcting the holes which are already exist. So, basically cylindrical holes correction in terms of the circularity and cylindricity, and their finishing is achieved through the honing process. So, these abrasive sticks are just like they are made of the bonding material and the abrasives. So, rotating workpiece, when rotating tool when interacts with the workpiece, internal surface of the workpiece, the material is removed from the internal surface in order to correct the hole dimensions as well as to give the desired surface finish. And normally high grit sizes are used for the finishing purpose, which can vary from like say like 20 to 80 for the roughing purpose, and 90 to 200 they are used for the finishing purpose. Means it is about the grit sizes which are used of the abrasives for the finishing purpose in case of honing. So, honing is basically the process used for finishing the internal surfaces of the cylindrical hole with the help of the hones, or which are basically comprises the abrasive sticks fitted all around the circumference of the hone. Then lapping is the another process wherein the tool, which is generally made of the like steel or copper or even of the lead. So, there is a tool as per the shape of the surface of the workpiece which is to be lapped, like say it is used for the polishing of the lenses or any other flat surface like this. So, as per the shape which is to be lapped, the tool is made like the shape of the object is like this, then accordingly the tool will be made. This tool can be made of the steel, copper or the lead, and between these two one slurry is placed. This slurry comprises either oil or kerosene plus abrasives, fine abrasives like silicon carbide and alumina, maybe like say 200 to 600 fine grit size abrasives are used depending upon the kind of the MRR or the RA is needed. The low grit size like 200 for high MR and for very low surface roughness, the high grit size like 600 is used. High grit size means fine abrasives, low grit size means the coarse abrasives. Coarse abrasives are used for the high metal removal rate, and so for high metal removal rate coarse abrasives, and for less roughness means better finish, high grit sizes are used. So, this slurry is basically placed between the lapping tool and the workpiece. Then under pressure this lapping is performed. So, the material, due to the relative motion between the abrasives and the workpiece, material is removed. There are two mechanisms which have been suggested for the removal of the material in the lapping process. One is that when the abrasives when tool is soft like lead, abrasives get embed in the tool. So, when the tool is rubbed over the surface on the surface of the workpiece, they remove the material by cutting. So, this is one case. Another one wherein this is the tool and the slurry is between the tool and workpiece. So, due to the movement of the tool, abrasives hit the surface of the workpiece and they cause erosion. So, due to the the impact as well as movement of the abrasives, and when they hit the surface of the workpiece, little amount of the material is removed. So, these are the two mechanisms which are considered for removal of the material. One, when the abrasives get embedded with the surface of the soft tools, and another is when the abrasives strike the moving abrasives hit the surface of the workpiece and cause the removal of the material by erosion kind of the process, while when they get embedded with the surface of the tool, basically the cutting. So, now here I will summarize this presentation. In this presentation I have talked various types of the operations and the grinding processes which are used for grinding the flat surfaces, cylindrical surfaces, cylindrical holes, and for realizing very high degree of the surface finish using various special processes also. Thank you for your attention.